Hello there, this is the video for week 3 of the course. So just to kind of recap, what we looked at last week was we looked at the idea of inference. So in other words, when you're given some information, what can you learn from that information? And hopefully you saw sometimes that can be kind of tricky. And it can be tricky because of how the information is displayed, or maybe there was some error when relaying the information. Now, in statistics and in many other fields, one of the most common ways to get some data in order to make inference about it is through an experiment. And so what we're going to focus on this week and next week as well is the idea of experimentation. And what you're going to find is that not all experiments are set up the same. If we have a poorly set up experiment, we're going to have some problems. In other words, the data that comes from that, we're not going to be able to make good inference from it. We really do need to have an experiment that is well thought out, and it needs to have certain things take place when that experiment is set up in order to get good inference from that experiment. Now, the first topic that we're going to look at today is going to be the topic of confounding. And so what happens in confounding is when a researcher is interested in looking at two different things in their relationship, but there's some third unknown thing that gets in there and interferes with good inference. And so let me give you an example of this. So suppose that I am a researcher and I'm interested if when a patient gets bed sores, if that's going to make the patient more likely to die. So in other words, do bed sores cause a patient to die? And so maybe what I would do is I would find a bunch of patients that had bed sores and didn't have bed sores, and I would try to figure out, are those with bed sores dying at a higher rate? And as you're probably not surprised, what I would find out is that patients with bed sores are dying at a higher rate. But the question is, does that necessarily mean that my experiment was good? In other words, did I show that there's a relationship between bed sores and bed sores and dying? And as nurses, I'm sure you're all going to tell me, well, bed sores don't cause death. What's happening here is patients that have bed sores are usually very, very sick patients that can't get out of bed, and they have other ailments and health issues. And it's those other health issues, that's what's, causing the patients to die. It just so happens that if you're really sick and you lay in bed for a long time, you get bed sores. So that's what confounding is, this third variable. So notice in this experiment I just described, I didn't study how sick the patients were. I only studied their bed sores and whether or not they died. By not considering that third variable, I had a problem. My inference wasn't very good. And you're going to see some other examples in the video today. And so one of the things we want to talk about this week, well, how can I set up an experiment to hopefully reduce the likelihood that I have confounding in my experiment? So in other words, what could I have done differently in my experiment so that I would have accounted for that some patients are really sick? And so what we're going to talk about today are two big ideas. They are comparison, proper comparison, and randomization. If an experiment has proper comparison and randomization, you reduce the likelihood of confounding. In other words, it makes better inference from that experimental data. Now, that's not to say that other things can't go wrong, and you'll see that as well, but those are two big things that we can do. So for any experiment, you're always going to check for what we call proper comparison and randomization. And the videos are going to talk about those things as well. Then the final big topic we're going to talk about today is something that is called statistical significance. And what that means is I went through, I looked at some data, I performed an experiment on some people, and I found a result. And so the question is that result meaningful enough that I can say that something is going on? In other words, whatever occurred didn't just occur by some random chance. And so when we can actually prove that something is occurring between two things, we call that statistical significance. And you're going to get just a glimpse of that idea here in Module 1. Now, later on in the semester, when we get to Module 3, we're going to talk about something that's called hypothesis test. And when we get to that point, we're going to have some more vocabulary and some more sophisticated ideas to work with, and we're going to revisit this idea of statistical significance. So today you're just going to get a glimpse of it, but later on in the semester, we're going to talk about this idea a little bit more and what it really means. And so those are really the big ideas from this week. We're going to look at experiments, how we can perform good experiments and what inference we can make from these experiments, and then also how inference might be bad if we don't have a well thought out experiment. So as always, if you have questions, I really want to encourage you, use that discussion board, ask me questions. That's what I'm here for. Anytime you feel confused, please just ask, and I will talk to you later.